All right, so we will continue our topical discussion. So this time I will be focusing on how to tackle to draw ray diagrams for lens and also mirror. And I understand that most students do not like this topic, especially the ones involving drawing the ray diagrams. Um, but I should tell you that this topic, especially the ones involving drawing the ray diagrams and identifying the characteristics of the image produced, will give a lot of marks during the exams. And drawing the ray diagrams usually contributes 3 marks, and to identify the characteristics of the image produced also will give you at least 1 mark until 3 marks. So this is a very important topic for you. So please pay attention on how to draw the ray diagrams, because it is not that hard. It's just that you have to know the rules in drawing the ray diagrams. The main point here is for you to get the intersection for 2 lines to get the position of the image produced. All right, so let's start. So we will begin. This one I have taken from your textbook. This one is taken from your physics form 4 textbooks. Okay, so here it shows how to draw the ray diagrams for both the convex lens and also the concave lens. Okay, so firstly, you have to know that convex lens act as a focusing lens. Okay, convex lens, it focus the light into one point, which is the focal point. And concave lens, it act as a diverging lens. Diverging lens means that the light as if emerged from behind. Okay, oh sorry, it emerged from in front. Whereas for the convex lens, because it focused, so the focus point will be behind the lens. Okay, so let's look at the comparison for each position of the object, okay, and the characteristics of the image produced. So firstly, there are 3 rules in drawing the ray diagrams. Okay, so the first rule would be the ray will pass through the optical center in a straight line. Okay, and since this is a lens is usually, we will focus the characteristic, it will refract. Okay, refraction of light. So depending on the surface of the lens, the light will bend. Okay, so the first rule is the ray of light passes through the optical center. And this one, because it passes through the optical center, it will not be refracted. Okay, so both convex lens and concave lens, if the ray passes through the optical center O, it will travel in a straight line without being refracted. Okay, that is the first rule. The second rule is for convex lens, the ray which is parallel to the principal axis is refracted and passes through the focal point F. Meaning, this one, it first travel parallel to the principal axis, and then it will be refracted to the focal point F. Okay, so remember, for convex lens, the focal point is after, or is at the opposite side. Okay, it is at the opposite side of the object. Whereas for concave lens, okay, the ray which travel parallel to the principal axis is refracted. Okay, it will be refracted, but it will appear that it will come from this one here. the focal point is at the same side of the object, not on the opposite side of the object. So if it is at the same side like the object, so it is a virtual image. So the lines that you should draw here, it should be dotted lines, indicating that it is virtual. Okay, this is for concave lens. Now the third rule is the opposite of rule number 2. So first, the ray which passes through the focal point, okay, at first it passes through the focal point, and then it will be refracted parallel to the principal axis. Okay, as you can see, it is opposite with rule number 2. The same goes for concave lens. So at first, it will go through F here. Remember that F for concave lens is at the opposite side. Okay, and then it will be refracted parallel to the principal axis. Okay, have we got that? Okay, so if we have got that, then we will start to practice drawing the ray diagrams for both of the convex lens and concave lens, and then I will help you to remember, to memorize, in how to memorize the characteristics for all the positions of the objects. All right. Okay, so at first, we will try to draw the ray diagram for convex lens when the object, all right? So please take note that U means object distance, okay? U means object distance, and F is the focal length, okay? F is the focal length. So here, U less than F means that the object is placed less than the focal length, like what is shown in this. Okay, so the red arrow indicates the position of the object in between the optical center and also the focus point. So that is less than F. Okay, so let's try and draw the ray diagram. So we will be using the first rule. Okay, so we will be using the first rule here. Okay, or you can also use the second rule, right? I will use okay. And then it will be refracted to F. Okay, so remember okay, so we'll try again. So we will start by from the top of the object, okay, top of the object, and then parallel to the principal axis, and then it will be refracted to F. Okay, it will be refracted to F. Okay, so it will be refracted there, and make sure to use a ruler for this one. And then the second one, you can use the first rule, okay, from the top of the object and then straight to the principal, to the optical center. Okay, from the top of the object and then straight to the optical center. Okay, something like that. And then as you can see, there is an intersection of the two lines. Okay, there is an intersection of the two lines there. And because it is formed in the same side like the object, so this is a virtual image. This will be a virtual image. And then you can draw the image here. This is I. And then because it is a virtual image, then you can do dotted lines here to indicate that it is a virtual line. All right. So this one also is dotted lines. Okay, dotted lines. So you will get 3 marks for this one. And then as you can see, the characteristics of the image, we will discuss about that later, but first I want you to really know how to draw the ray diagrams according to the position of the object. Okay, the second one is when the position of the object is exactly at F. Exactly at F. So again, you can use the first rule to draw the lines there from the top of the object and then straight to optical center. Okay. A bit hard for me to draw exactly the lines because I'm using my iPad. So if you are okay. So the first line is by using the first rule from the top of the object and straight to the optical center. It will be refracted to the optical center. And then the second one is from the top of the object parallel to the principal axis, and then it will be refracted to F. Okay, it will be refracted to F. Okay, please don't forget to draw the arrow to indicate the direction of the ray of light. Okay, so it will be refracted. And then as you can see, there is no intersection of the two lines drawn. It means that the position of the image is at the same side like the object, but it is very, very far away, and the size of the image is very, very big. Okay, so it is very big, so we assume that the position of the image will be at infinity, right? Infinity, so it is a virtual image also. And then do not forget, this is a dotted lines to indicate that the image produced is virtual. Okay, the next one is when the object is placed in between F and 2F. Okay, it is placed in between F and 2F. So we will try and use rule number 2 and rule number 3 to get the position of the image. Okay, so for rule number 2 is from the top of the object, and then it will be refracted to F. Okay. refracted to F, and then we will try and do the second rule. Okay, it is the opposite of rule number 2 just now. From the top of the object, okay, and then it will be refracted to F first. Okay, and then parallel with the principal axis. So as you can see here, the red line does not intersect with the blue line. So what you should do is you extend the line. You extend the line, right? You extend the line until it intersect with the blue line, all right? So you will get an intersection there. So that is the position of your image there. Okay, so you can see it is formed at the opposite side of the object. Okay, so it is a real image and inverted. So real image, you just draw a solid line and not a dotted line. Okay, so this is for when the position of the object is in between F and 2F. Okay, right now we will try and draw the ray diagram for when the object is exactly at 2F. Exactly at 2F, or you can say that it is exactly at the radius. So we will be using the second rule from the top of the object, and then it will be refracted to F. Okay. All right. Then the second one, we will be using, okay, the first rule from the top of the object and then straight to the optical center. Okay, so the blue line did not intersect with the red line, so you have to extend. Okay, extend the line. So you will get an intersection there. And as you can see, the position of the image is exactly here. This is the position of the image, exactly at 2F also. And the size of the image is the same like the object. Okay, how do you determine the size of the image? For example, here you can measure the size of the object is, it takes 5 squares, 5 small squares, so we assume that it is 1 centimeter. Okay, so the size of the image produced also takes 5 small squares, so it is equals to 1 centimeter also, right? So this is how we get the image produced. Now the next one is when the position of the object is more than 2F, more than 2F. So again, we will be using, I will be using the second law first. Okay, from the top of the object. Okay, and then it will be refracted to F. Refracted to F. Okay, and then the second one is from the top of the object and then straight to the optical center. Okay, so again, the size, the blue line does not intersect with the red line, so you extend it. You extend it, and then you will get the intersection of the two lines there. All right. Okay. Then the last one, the last one is when the position of the object is at infinity. Means the object is at far away, very, very far away, like the stars. Okay, so how do we draw? So it is still the same, but since the position of the object is so far away, so we only can assume that it will pass through F. Okay, it will pass through F, refracted to F, and then the other one is it will be okay. So we will be using the third rule. Then refracted along the principal axis. So you will get the intersection of the two lines somewhere around here. Okay, this is the position of the image. Okay, so that is how you draw the ray diagrams for convex lens. Okay, let's see the characteristics of the image. All right. Okay, this is what the summary of all the formation of image by the convex lens. Okay, this one was, the first one was the object is at infinity. Object is at infinity. It means that it is far away. All right. So as you can see here, the image produced will be at exactly at the focal point. Image is at F. And then if we compare the size of the image with the object, it is real because it is at the opposite side of the object, and inverted, and also smaller, diminished. Okay, so we will be using this code RID. Okay, RID, real, inverted, and diminished, for the characteristics of image. That one is for when the object is at infinity. Okay, the second one is when the object is more than 2F. More than 2F. So as you can see here, the image produced is in between F and 2F. And we can see that because it is at the opposite side of the object, so it is real, inverted, and diminished also. So this one, the code is RID also. Okay, RID. Okay, the next one is when the object is exactly at 2F. It is exactly at 2F here. And we can see that the size of the image is the same. It is formed exactly at 2F also. So we can say that the image is real, inverted, and same size. We put S. Okay? We put S there. Same size. Wrist. Same size. Or you can also put SS. Same size. Okay? Doesn't matter. Wrist. Okay, next is when the object is placed in between F and 2F. Okay, placed in between F and 2F. And we can see that the image is formed at the position of more than 2F. And the size of the image is magnified. Size of the image is magnified. So real, inverted, and magnified. M. RIM. Okay, and next one, the object is exactly at the focal point, and we can see that the image is formed at infinity. Image is formed at infinity means that the image is formed at a very far place. Okay, and because it is formed at the same site like the object, so we can say that it is a virtual image. And it is upright and magnified. Okay, VUM, virtual, upright, and magnified. And lastly, the position of the object less than F. Okay, as you can see here, the image form is more than the position of the object, and it is at the same side or like the object, so it is a virtual image, upright, and also it is magnified. Okay, so this one, the last one, an example of application for the last one is the magnifying glass. Magnifying glass, where the position of the object is nearer to the convex lens. It's like you want to magnify the ends so you can see it better. So you will place the magnifying glass nearer to the object so that you can see it clearly, and it will be magnified. Okay, so you can see here, the code here is read, ris, rim, vum, vum. Okay, so I will help you to memorize on how to memorize this, the characteristics of the image. It is actually very simple. Okay, it is actually very simple. All you need to do is, at first you draw the vertical line and also the horizontal line. So the vertical line indicates the lens. Okay, these vertical lines indicates the lens, right? Indicates the lens. And then just put F, okay? I put here F and then 2F. F, 2F. The same goes for the opposite side, F and 2F. Make sure that the distance is the same. So I will be using 5 basic position of the object. Okay, I will be using 5 basic position of the object. The first one is, okay, first one is when the object is more than 2F. Okay, so let's say this is the position of the object, more than 2F. Okay, so I will put this one. This is number 1. Number 1, position of the object is more than 2F. More than 2F. Right. Second one, the second position is exactly at 2F. Okay, the position of the object is exactly at 2F. This is position number 2. Object is exactly at 2F. Third one, the third one is the position of the object is in between F and 2F. Okay, so you can see here, the position of the object is in between F and 2F. So you can write down there. The number 3, this is number 3, not enough space, sorry. U less than F, more than 2F. Okay, in between. Okay, and then the fourth one, the fourth position would be when the object is exactly at F. Exactly at F. This is number 4. Exactly at F. And then the fifth one is when the position of the object is less than F. Okay, less than F. Okay, less than F. Now, if we refer back, okay, if we refer back the previous diagram here, okay, if we refer back to the previous diagram, the code written there is read, ris, rim, voom, voom. Okay, according to the position of the object. Okay, read, ris, rim, voom, voom. So you can say that this one is, okay, I will put there. Read, ris, rim, voom, voom. Okay, so when you get this type of question in the exam, either it is in paper 1 or in paper 2, so the first thing that you should draw is this. Okay, this is the first thing that you should draw. The position of the object, like what I have shown here with the 5 green arrows, and then the characteristics of the image, 3 characteristics of the image. Okay, so read, ris, rim, voom, voom. So you remember that one. Read, ris, rim, voom, voom. Okay, because the characteristics of the image, usually it is either real or virtual. Okay, real or virtual, R or V. And then in terms of either it is upright or inverted. Okay, inverted or upright. Each one is 1 mark. Then third one is the size. So either it is diminished. Diminished means smaller. Same size or magnified. Okay, magnified. D, S, M. Okay, so 3 marks for the characteristics of the image, plus with 3 marks with the ray diagram. So you will get 6 marks. So it's quite a lot of marks for this drawing the ray diagrams. And I hope that you can do well for this one lah. Okay, and that is for convex lens. Now I will show you how to draw the concave lens and also the mirror, and then you can see what is the similarities. Okay, the similarities for both of the ray diagrams situations, right? And okay, for concave lens, how to draw the concave lens, because the F is at the front. So again, it is the same. We do the second law from the top of the object. Okay, top of the object, and then it will be refracted in front because F is at the front. Okay, will be refracted here. And since it is refracted in front with the same side like the object, so it is a virtual image. Now let's complete the ray diagram with the second part. Okay, from the top of the object straight to the optical center. Okay, straight to the optical center, and then as you can see, there is an intersection between the two lines. Okay, don't forget to okay, so this is the intersection to produce the image. Okay, because the arrow is quite small, so it should be actually it should be dotted lines because it is a virtual image, right? So this is the image there. Then the same one, when the object is placed less than f, you use the same rule. You use the same rule from the top of the object, and then it will be refracted to f. Okay, it will be refracted to f. And then the second one is we use from the top of the object and then straight to the optical center, refracted to the optical center. So we will get the position of the image is here. Okay, so there is no matter where the position of the object for concave lens, this is for concave lens, no matter where the position of the object, it will always produce the same characteristics of image, which is VUD. Okay, so that is the characteristics of the image produced for concave lens. VUD, virtual, upright, and diminish. Okay, virtual, upright, and diminish. That is for concave lens, right? So I hope you understand in drawing the ray diagrams for both of the concave lens and also the convex lens. Okay, and then later on we will summarize what is the similarities between all of these ray diagrams. Okay, so we will continue. Okay, we will continue in drawing mirror for the case involving concave mirror and also convex mirror. So it is actually the opposite of the characteristics of the ray diagrams using lens. Okay, so concave mirror, as you can see here, because mirror, the mirror, it reflects, memantulkan. Okay, it memantulkan. If lens, it refract, membias, it bends the light. But this one mirror, it reflect. Okay, dia pantulkan cahaya. So for concave mirror, as you can see here, the concave mirror, concave means it is curving outwards. And because it is curving outwards, all the reflected rays will be focusing on one point. So the focus point for concave mirror is at in front, the same side like the object. Whereas for convex mirror, because it is curving inwards, so the reflection is as if the position of the focal point is behind the mirror. So if it is positioned behind the mirror, it means that the image produced will be virtual. Okay, so it will be virtual. So if virtual, then you have to draw dotted lines. Okay, so let's see in how to draw the ray diagrams. It's actually not so different from drawing the convex lens. Okay, so for concave mirror, we will be using 3 rules also to draw the ray diagrams. The first rule is the ray of light passing through C and then reflected back to its original path. Okay, so make sure that you don't forget to draw the direction of the ray after it is reflected. It is very important that you draw. If you don't draw the arrow, direction of the arrow, then you will lose 1 mark. Okay, from 3 marks, then you will lose 1 mark. You have to draw the direction of the arrow, indicating that it is reflected. All right. So the same goes for convex mirror. Convex mirror, it is reflected towards C and then reflected back again. But remember that because convex mirror is virtual, so all the lines after behind the mirror will be drawn with a dotted lines. The second rule, this is the second rule. Okay, for concave mirror, the light ray parallel to the principal axis will be reflected to F. Okay, it will be reflected to F. And for convex mirror, okay, parallel to the principal axis, and then the F is at the back, behind the mirror. Then the third rule, this is the third rule. Okay, light ray passing through F. Actually, this is the opposite of rule number 2. Okay, if you notice that this is the opposite of rule number 2. Okay, the light ray passing through F is reflected parallel to the principal axis. Okay, for convex mirror, so we'll go to F and then reflected to parallel to the principal axis. Okay, so that is the 3 rules. So again, we are going to find the intersection between the 2 lines there. Okay, all right, so this is an example, ray diagrams for concave mirror. So we will be using, okay, right, don't forget to draw the arrow. So it will be reflected to F. Okay, second rule is directly towards, actually I'm using the third rule, the opposite of rule number 2, right? Don't forget the arrow, and then it will be reflected along the principal axis. So you will get the intersection of the 2 lines here. Okay, this is the intersection of the 2 lines between the red and the green line. So you can see that if you compare the object, the characteristics of the image would be real, inverted, and diminish. Okay, RID, real, inverted, and diminish. Okay, so the next one is when the object is exactly at 2F. So again, I will be using the second rule from the top of the object. Then it will be reflected to F. Okay. So this is the position of the image. Okay. Then this one, when the object is in between, okay, the same top of the object reflected to F. Second one. Okay. So you can see the position of the image is here. Okay. Then this one is real, inverted, and magnified. Bigger rim. When the object is exactly at F, what happens? Right. And then the second one. Actually, the image will be produced at the back of the mirror. So means that you have to extend this line at the back there. Okay. Extend the line at the back there. So the image produced would be virtual. Okay. Virtual, upright, and also magnified. So it will be reflected here. Don't forget that the lines behind the mirror would be dotted lines. So you can write here, it is virtual, upright, and magnified. Okay. This one also the same. This one is the same. From the top of the object and then reflected to F. Okay. So you have to extend the line. You have to extend the line so that it will be formed behind the mirror. Okay. Okay. All right. Like this one. So image produced is here, intersection. Don't forget to make it into a dotted lines. Okay, dotted lines. So this one is also virtual, upright, and magnified. So for okay, this is the final diagram lah for all the that we have discussed just now that I have shown you. Okay. So again, it is the same. This one, object is at infinity, real, inverted, diminish. Okay. Object is at infinity. This one, object is more than 2F, so read. The code is read. When object is exactly at 2F, RISS, RIS. Okay. Then this one, object is in between F and 2F. So it is real, inverted, and also magnified. Then object is exactly at F. It is virtual, upright, and magnified. And the last one is when the object is less than F, also the same, virtual, upright, and magnified. Okay. This is the only thing that you should remember lah. And it is the same like what I have drawn for convex lens. The concave mirror characteristic is actually the same like the convex mirror, the convex lens. So you can say that this one, then the characteristics of the convex lens is the same like the concave mirror. Concave mirror characteristic is the same. Okay, provided that you draw first the position of the object like what I have shown you here according to the numbers. All right, so that is how you can memorize lah. You can memorize. And then for the characteristics of, I put here, characteristics of the concave lens, it is actually the same like the characteristics of convex mirror, and that is virtual, upright, and diminish. Okay, so that is the conclusion that we can make for the ray diagrams for lens and also mirror. So I hope this one can help you to understand and score well if you ever get these type of questions in your exams. Okay, so if you have any questions, then you are always welcome to ask me. Okay, so that is all for this one. Thank you.